Okay, so in this class, we're majorly going to be focusing on C# classes, majorly object-oriented programming using, oh, I said C#, JavaScript. Sorry, I do C# too, and I thought the topic yesterday. So we'll be looking at object-oriented programming today using JavaScript, and basically JavaScript is not really one of the core OOP languages we have, but JavaScript has the concept of classes and code that we use to implement OOP in JavaScript. So that's what we'll be focusing on today. So to get started, I wanted us to first of all discuss on what an object is. Okay, what an object is. To understand how object-oriented programming works, I would like to bring us back to our own life, everything we deal with in our own individual lives. Now, as a human being, if you look at virtually everything around you, you'll discover that you can actually classify them into various categories or classes. Let's use the word there. So you can always classify them into various categories or classes. Basically, what an object is, the definition we got from an object is that it is basically anything around you you can see, touch, feel. If you go to Google now, it gives you those kind of definition. But what I want to point out there is you will discover that virtually all the objects around you, I'm talking about your table, your car, your chair, your TV, even you as a person, you can pass as an object. Everything, if you look at it down, you will discover that you can classify everything to different categories. Let's start with the animal kingdom. Okay, if you start with the animal kingdom, you discover that even the different types of animals you see, you will see some similarities between them that classify them as animals. Okay, there are things you would see in an animal right now. You'll be able to say, oh, this is a dog, this is a cat, this is a bird. It's because of the features that animals have, that particular animal have, that you can classify them into that category you are classifying them to. So if you look at a bird now, what are those common features a bird have that you will use to classify it? You will look at, oh wow, it has wings, it can fly. It has two legs, it has a back, it has this color, it has a tail, and so on and so forth. So because of those things you can point out, okay, that you can pick out, you can easily classify that, oh, this is a bird. Now, basically, when we are looking at objects, okay, there are two common things objects have. Okay, objects have what we refer to as properties. Okay, objects have what we refer to. Are you asking a question? All right. So objects have what we refer to as properties. The properties are basically those features. Okay, you can either call it properties or features, or basically you call them attributes. Or sometimes you can still call them characteristics. Okay, but in this class, I'll just go ahead and call them properties. So objects have these things we refer to as properties. What are the properties of an object? It is basically those things that you can see when you look at the object. Those things you can easily point out. For example, I made mention of the fact that a bird has two legs. It has wings, two wings. It has a back. It has a tail. Those things that I can point out in that object are the properties. Then we objects also have what we refer to as actions. The actions are basically what the object can do. Okay, those things that the object can do. For example, now a bird now can fly. It can walk. Are we together? So those things are what we refer to as the actions of the object. So if you can keep these two things in mind, understanding the rest of this class or understanding the concept of OOP will be very easy for you. Okay, now in programming, what programmers now decide to do is when we are programming, we try to mimic this behavior of the real life objects into our code. Okay, now we are using birds as an example. this same concept cuts across virtually all objects around you. Take yourself as a human being as an object now. There are some properties or characteristics that you have. For example, now you have 2 eyes, you have 2 hands, you have 2 legs, you have a head, you have a nose, you have an ear. Those things are what we refer to as the properties of the human being now. Then, as a human being, you can walk. That is an action. The things you can do are the actions there. You can walk, you can talk, you can sing, you can shout, you can jump. Those are the actions that are attributed to you. Are we together? Now, this thing cuts across, like I said, all objects. There is no object you will pick out right now that will not have these things. They would always have the properties. Properties are those things that set the object apart. Those things you can see and use to identify the object. Then there are the actions. The actions are those things that that particular object can do. Okay? So, now these 2 things, if you look at it, now, generally in object-oriented programming, we try to mimic these things in our code. Okay, before OOP, we used to have this method of programming. I think if I remember it correctly, it should be procedural programming or so, where we just write code. And the problem with that approach was it basically led to what they call spaghetti code. Things just happening everywhere. We can't really trace where it is happening from, unless of course you have to spend time looking at the code and studying it. So in programming, we try to mimic this method of we try to mimic this thing we see in objects around us, and that is where the concept of object-oriented programming comes in place. Now, in every programming language, whenever you create an object or you want to create an object, you would have to set properties for that object too and actions for that object. But we don't call them actions now, we call them methods. For those of you that have been coding for a while, or you've written any code before and you've heard of the word method or functions, we call them mostly functions in JavaScript. Okay, if you've seen this before, I'm sure you know what functions are. They are just a piece of code or a block of code that you write to perform specific actions or specific tasks, and that passes for the actions we are talking about. So in the real life, most objects in the real life had properties or characteristics. In programming, we still refer to them as properties or methods. Now, where does the term classes now come into play? Where does the term classes now come into play? Now, before we go ahead and talk about that, to quickly understand the relationship between properties and method, you know, if you look at a bed, for example, now, and we want to list out the properties of the bed like we did earlier, let's list out the properties of a bed. Let's use a bed as our object now. If you look at the bed, some of its properties will include what? Let's say things like it has 2 legs. Okay? What else does the bed have? Let me try to expand this a little so we get
wings.
You have a question? All right. Okay.
No, I'm pointing out attributes of the bed.
Okay. Oh, thanks for that. Okay, so it has wings. Let's look at another thing the bed has. Which other thing do we think a bed has? It has legs. Okay, which other thing? It has it also has the tail. AL, yeah. What other thing? Let's just stop there. Now, if you come to the methods or actions, okay, I told you we refer to them as method or actions. If I use them interchangeably, you should know what I mean by that. If we come to the methods now, the methods are talking about the actions that can be performed by the bird. What can the bird do? You will discover that a bird can fly, but you see, the relationship between the methods and the action is whenever this bird wants to fly, it uses some of the properties to perform the action it wants to perform. If this bird wants to fly now, what will it use to fly? It uses its wings, right?
The wings.
Of course.
Yeah.
So you can see that the methods now or the actions sometimes or mostly depend on the properties. So it uses the properties to perform those various actions. If you look at another action a bird can perform, it can obviously walk. So it lands down and walks around. What does he use in walking? He uses what? He uses its legs again. This is where the legs comes in. So these are the common things you will notice in a bird or in any object around you. All objects would have properties and they will have methods. The properties are those physical things you can see in the object. The methods are those actions or those things that the object can do. For example, now let's take another object that we are familiar with. Let's take a car as an object. If we are to list out some of the properties of a car would have a color. It will have numbers of wheels. So let's say numbers of, let's just do NO wheels. We are not coding yet, so anything goes. So let's say numbers of wheels. What else is common about a car? It might have numbers of doors too. Not all cars have the same numbers of doors. So we can say numbers of doors. Now, these are the common features of a car. A car can also have its make, what brand it is. So is it Ford? Is it Toyota? So it can have a make. Another thing might be the model. A car can have a model. Another thing a car can have is the VIN, which is the vehicle identification number. All these are some of the properties of a car. Let's talk about the methods of the car. So if we want to look at a car now, a car can move, or you call it drive, or whatever you want to call it. It can reverse. It can do all of those things. It can speed. Those things are the actions of the car. Now, in programming, whenever you're writing sometimes, you might need to deal with these real-life objects in your code. In fact, in object-oriented programming, we try to treat everything as an object. And that is why when you're coding with languages like C#, Java, C++, see, you must understand object-oriented programming to even get started with the languages and say, yes, you know the language. It's not like languages like Java or JavaScript or Python, where you can still write, you can build most of you can write up your code base without implementing OOP. So some languages like Java, C++, and C# are built on object-oriented programming. So in JavaScript, we can still do this, and that is what we are trying to look at in this class. So let's see a typical example of where you might need to deal with an object or why you might need to deal with an object. Let's say we're writing a JavaScript program that will be dealing with, let's say we're building an e-commerce app. And we know in this e-commerce app, we are going to be dealing with a lot of different products. Now, you will know that there are some common things about a product. Each product will have its price. Each product will have its title. Each product will have, which other thing is common about a product? Maybe the seller or whoever is selling the product. Now, if you look at this now, this is just more than what a regular variable in JavaScript can store for you. Okay, you can't just go to your JavaScript code and say, create a variable and say something like const name, product name equals to iPhone 14, const product price equals to 25,000, const product date. How many variables are you going to create to actually house all of those data about a singular product? So in object-oriented programming, what we do is this. We try to create a class and then create instances of that class. I know I've just gone a bit too far, but let me explain what I mean. If you remember when I was introducing you or when we were discussing about object-oriented programming, I talked about the fact that all of the objects around you, okay, all of the objects around you, if you look at them well, you can classify them into different classes. For example, if you look at the animal kingdom now, okay, you can actually bring most of the animals under a class called animals. the human too, if you take a human being, either he has white skin, he has black skin, he has long hair, you can still classify them as humans. Right now we just talked about cars, but if you talk about car can belong under the class of vehicles, if we think of it well. Because under the class of vehicles, you can have different types of vehicle: a car, a truck, a lorry, a bus, and so on and so forth. So in object-oriented programming, before we start creating objects, what we do is we try to create the class for the object. Now, what is a class? A class is just the blueprint or the template. Let's call this the blueprint. You can call this the blueprint or a template for creating objects. So a class is a blueprint, let's just say a blueprint or a template for creating objects. What do I mean by this? Now, why do we even need classes? Let's try to answer these questions. Now, if in my code, right, I'm trying to create an object of a bed now. Okay, let's say we want to create an object of a bed. So I want to create an object of a bed. So I say bed, that's the name of the object. And the properties I want to give to this bed are maybe wings, or let's go with car. I want it to be a bit more relatable. Let's go with car. Let's say this car will have property like doors, which are the numbers of the door. It will have properties like the make, which will be the brand of the car. It will have properties like model, which is the particular model of the car. Then it will have methods, okay, which are the things the car can do. So the method might be like the car can move. Okay, that's a method. Which other common property and methods will a car have? Let's say it can also speed. Okay. Now, if this is the object I want to create in my code. Now, there is tendency that if I create a car with all of these properties and methods, and I want to create another car, I might make a mistake in rebuilding the new car because I am not following a template. This is what I mean. Imagine Apple now come up with the idea of a new iPhone. Do you know the first thing that Apple will do? They will first of all try to create a plan, like a detailed plan, a blueprint, a template on how to create the product. The reason they do that is because next time when they need to create another product, another model, they can create the product following that initial blueprint they have designed. Are we together? For those of us who do technical writing or any thing that has to do with writing, you discover that before you even try to publish your article, you would have initially had like a sketch or a draft, so that when you're writing the article later, you follow the draft and then lay out all of your article. Or let's say we are a car manufacturing company now, and we are the one manufacturing Camry. Have you ever looked at all the Camry cars? For those of you who have met one, have you looked at all the Camry cars? You will discover, if you look at them, you will discover that they are always the same. Fine, the color might be different and things like that, but the functionality is always the same. Why is it like that? The reason is because whoever made the car, when they were making the car, they followed a specific plan, a specific template in making it. If they don't, you will discover that this car might have a particular function that is not in the other car. This car might have a particular feature that will not be in the other car. Of course, they can do it on purpose. But the point I'm trying to make is, in programming, whenever you want to create an object, one thing we do first is to create a class. And the purpose of creating the class is so that we have like a template, a blueprint to follow, so that whenever we are creating the object, we can create objects that matches the class that we created earlier. Now, let's look at another example. Let's say if you look at most architects that build houses now, the very first thing they do before they build the house, don't forget the house here is the object, okay? Just like the car is the object. The house right now is the object. most architects that build houses, they will initially make a structure. They call it the architectural drawing for the house, or sometimes they call it the blueprint of the house. They initially make a blueprint, which is like a drawing, a diagram that will lay out everything they would put in place for the house. So from the foundation, where the blocks will start from, the size of the room, everything will be in that blueprint. Now, if you give me a blueprint, if you give an architect a blueprint to build a house in Lagos, if that architect take the blueprint to Abuja, he will still be able to build the same house. And when you look at the houses, they will be identical. But tell an architect to build a house in Lagos without giving him a blueprint and tell him to go and replicate the same house in Abuja, you will discover that one or two things might be off. Probably the measurement of the room might not be the same, because he forgot, oh, the master bedroom, it was this measurement he used. Then he goes to the other place to do another thing. But if he has the template, the architectural drawing, the blueprint for the building, he will be able to replicate the same building anywhere in the world. And that is why in object-oriented programming, whenever we want to create objects, the first thing we do is create a class. Okay, lay out the blueprint. The class is what will contain the details of what and what the object is supposed to have. For example, now, if we look at this car right now, I told you that this car now can be like, since it's an object, if we want to trace this down more, or let's say we want to start manufacturing cars in our company, we don't just go down to start building the car. The very first thing we are supposed to do, okay, is to lay out a plan. Draw a plan of, okay, this car we are going to make, which feature or which properties is this car going to have, and then what functionality are we going to give the car? Should it be self-driving? Should it be automatic? Should it be manual? So the first thing we would have to do is sit down, lay out a structure and say, okay, you see this car we want to make, okay, the car must have 4 doors. That is a feature, that is a property or a feature there. Then we would say, okay, the car would have so height. So we say, okay, if it's going to have a height, the height will be like maybe 3 feet. I don't know the measurements they use when doing their cars, but I'm just going to throw any measurements there. Let's say 5 feet. Okay, which other thing should this car have? Okay, we want it to have 2 seats in front, 3 seats at the back. So we would say, okay, a total of 5 seats. This thing I am doing right here is like I'm already creating a plan for creating a car later, so that whenever I want to start creating the car, all I have to do is follow this plan. And if I follow this plan, even if I make 20 cars, you will discover that all the cars will be identical. Of course, I can change the color of the car. I can decide to make it blue, white, or green. But the most important features of the car will be the same. Why? Because I followed the same plan in making all of the cars. Now, most programming languages will not, most OOP, object-oriented programming languages, will not allow you to create an object without creating a class. But JavaScript is one of the only exceptions I've seen. I don't know if there's another language like that. I'm just speaking in terms of the knowledge I have with JavaScript. It's in JavaScript I know that you can create an object without creating a class for the object. Of course, a lot of us have been programming that way, but we can still use the regular object-oriented programming in JavaScript, where we first of all create a class, and then after creating the class, we create an object from the class. Now, let's go to code and see how we do this in action. I'll be using Visual Studio for this class, so I'll just create a new folder here, and I'll call it JS OOP. All right, I'm going to open that folder up in Visual Studio. Visual Studio Code, sorry. So where's the option? Show more option. Open with VS Code. All right, perfect. Now, I'll just create a JavaScript file. Okay, so I'll just do app.js. For those of us that were in the last class, you will notice that throughout when I was coding in the last class, I did not really use an HTML file. But since we have some people joining us today that were not in the last class, let me zoom in a bit. Since we have people today that are joining us that were not in the last class, I might have to explain how we work, because I don't want anyone to be surprised as to why does he not have an HTML file and he's writing JavaScript code. So normally what we know, okay, is that whenever you want to create a JavaScript file, you need to have an HTML file, because that's the only way you can load the JavaScript to the browser for the browser to read it and interpret it for you. And that is correct. So if I come here now, create an HTML file, I call this index.html. Now, if I call this index.html, now in Visual Studio, you can auto-generate code. We are not dealing with basic HTML in this class, so I'll try as much as possible not to talk about it. So I just generated this. I'll call this JS class, or let's just leave it as JSOP. Now, the normal thing we know is you either put your JavaScript file in the body tag or in the head tag. You can put it in the head tag, so create a script tag and link to it src. The src is like the source, the location of the JavaScript file. Now, because this JavaScript file is located in the same folder as my app.js, all I have to do, I mean, the HTML file and the JavaScript file are in the same folder. All I have to do is just call the name of the JavaScript file, app.js. If I save this now, I come to JavaScript. Let me open my JavaScript and I do a console.log. Let's just log hello from here. If I save this, now this is my HTML file. You know I've included my JavaScript file. If I open it up in the browser, okay, live server. Oh, it's showing up on my other screen. Let me bring it to this screen here. Okay, if we inspect, right click, go to inspect, and I come to my console tab, you see we get our hello from here. All right, we get our hello from here. But because I don't want to be going back and forth, opening the browser, refreshing and all of that, all the code I'll be writing today, I will not be running it in the browser. I'll be running it in my terminal. In Visual Studio, whenever you have Visual Studio, if you have Visual Studio installed, you see this option that says terminal. If you click on it, you can create a new terminal. And using this terminal, you can run your JavaScript code. But in order for you to run your JavaScript code, you need to have Node.js installed. Now, don't miss what I just said up. If you are going to run your JavaScript in your browser, you don't need Node.js. You only need it if you want to run your JavaScript code in your terminal. For those of you who don't know what Node.js is, it's actually a more of a library, okay, used by JavaScript developers to build back ends majorly. And for those of you that do front-end development using frameworks, I'm talking about frameworks like React and Vue.js and co. You would need Java Node.js for that. I already have it installed. If you don't have it and you want to install, you can just search for Node.js, go to their website, and on their website you want to download it here. I recommend you download this first option that has LTS. LTS means long-term support. Unless you have a reason for downloading this, just go with this. Once you have Node.js installed, you can now run JavaScript code in your terminal. To do that, all you have to do is open that if you're in Visual Studio, you want to open your terminal. So right click on terminal, new. That will create a new terminal for you. And you want to type in node followed by the name of the JavaScript file you want to execute. In this case, app.js. You see, I get my hello from here, which was that output, which was the console.log we have here. So I'll be using this to run our JavaScript code, so I don't have to go back and forth. It's always tiring to open your browser, refresh, check code, come back to VS Code. All right. So in JavaScript, I've already tried to explain the basic things surrounding classes and objects. Just keep this at the back of your mind. Objects are the real things, okay? A house is an object. A car is an object. You as a human being, you're an object. Class is the blueprint for creating the object. So the plan you follow in creating the object. Once you understand these two things, you are halfway to understanding OOP. So in JavaScript, I know some of us are already used, most especially if you're in the last class, you're already used to the fact that if you want to create an object in JavaScript, all you have to do is just create a variable like, let's call this a product, and you set it equal to curly bracelets. Then inside this curly bracelets now, you can say name, colon, you give the product a name, comma, you say something like price, or let's go with a car object. I don't want us to be using different objects as an example. So this car object now will have a make. It will have a, let's say the make will be Toyota. Another make. Another common property of a car is the brand. Oh, the brand is already in the make. I mean the model. So this model maybe might be Corolla. I don't know if I spelled that correctly, but we are here to code, not to look at spelling. So forgive me for that. All right. And let's say the price of this one will be around, let's just say 25K. We both know that's a lie, but let's just leave that. And maybe another common property of a car is the year. So maybe this will be 2020. I don't really remember the year of that, but let's go with 2023. Now in JavaScript, we can create an object like this, and you can also give the object, these things I listed here are the properties. Don't forget the class we had earlier, the discussion we talked about. All objects used to have properties and actions or methods. So these things I listed here, we can refer to them as the properties. They are the properties. Then if you want to give it methods, we can say it has a method like move, which will be a function, okay? And this function we just say, let's just do a console.log the car is moving. Let's put this as a string. So let's throw this in a string. Now this is how most of us might be used to creating objects in JavaScript. If you attend the last class, this was how we created our objects. Like I said, JavaScript is one of the only languages I know that would allow you create an object without having a class, that is having a plan for creating the object. Now, the problem with creating an object like this is that because you are not following the principle of using classes, it's prone to errors. What I mean is this. Imagine we created an object called car1 here, and then we want to create another car. We call it the const car2. This will be another object. Now there's tendency that when I'm creating this car2, I might forget to add a particular property to it. And when that happens, because I already think that all my cars, let's actually do it. Let's do it. So I can come here, create this now, and forget to add the model to it. You see that this car now has a model, this one doesn't. And then because when I was creating the first object, I know I add a model, and I'll try to access, imagine I'll now come down, I'll say car2.model. But if you look at car2, there is no model there. This can cause my code to break. And this is happening because I forgot to add a model to car2 when I know that all my cars are supposed to have model, like car1 has a model. So I was expecting car2 to also have a model, but because there was no plan for creating it, I was just creating it, I forgot to add a model to it. Now, if we are to use the principle of using classes to create objects, now let's look at how we create a class in JavaScript. So to create a class in JavaScript, we use the class keyword, okay? So we just say class, Okay, that's how what you just do. Next is supposed to be followed by the class name. Okay, next is the class name, then curly bracelets. Now, inside the class, we always had what we call a constructor. Don't worry about that terminology. I would explain what it does later. But what we are supposed to put next is a constructor, and it just goes like this, something like this. Now, this is the template for creating a class. This is the structure of a class in JavaScript, and nothing more than that. This is how we just create classes in JavaScript. Now, once you do this, the next thing you want to do or in your class is go ahead and specify all of the properties of the class. And now we do that inside the constructor. We do that inside this constructor. So we were looking at a car earlier today. So, and we said that this car is going to have a make. If you remember, oh, I think I've deleted it. But we said it was going to have a make, a model, a year, and what else again? Let's just go with those three. So a make, a model, and year. Now, when you want to create this class of the car, now we want to call this class vehicle, or let's call it car. That's the name of the class. Now, it is common practice in JavaScript that your class name starts with an uppercase. Okay, you want to always start the name with an uppercase. You can start with a lowercase and it will still work. But the thing is this, in JavaScript, it's recommended that you start your classes with uppercase and your functions with lowercase. So if you mix them up together, you might mistake a class for a function and a function for a class. And believe me, in programming, you have enough headache to deal with than to deal with the headache of not knowing if you are calling a class or a function. So always start your class with an uppercase. It is just recommendation. It is not a must. All right. Once you give the name of the class, inside this constructor open and close bracket is where you want to register all of the class properties. Okay, that is where we want to register all of the class properties. So this class now, we can come here and say this car should have a make, comma, it should also have a model, comma, and it should have a year. And then inside this constructor, we are going to do something. Like I said, I would explain what this does, but for now, just look at the code. I'm going to do something like this dot year. Okay, let's start with the make. This dot make equals to this make that was passed here. And then we'll do the same for model. So I'll say this dot model equal to this model. And lastly, this dot year equal to this year. Now, this is just a basic class we have created. Now, if you look at this class, basically, this is what we are doing here. We are creating a template or a blueprint that we will use for creating a car object later. Right now, we've not created a car object. We just created the plan for creating a car. That is what we have just done. And we have stated that all of our car must have a make, must have a model, must have a year. And then what we are doing here, we are using the this keyword. Okay, now the this keyword refers to the object we are creating with this class. When we create an object, I'll come back to explain this because it will be clearer to understand it then than to understand it now. So I'm just going to leave that. Now that we have created a template for creating a car, we can then go ahead and create a car from this template. To create a car from this template, I can easily just say const car, let's call this Toyota, const Toyota equals to, now instead of saying equal to curly bracelet, you know, this is how we have been creating objects before. We just put curly bracelet. But like I told you, if you create an object like that, you are not using the class approach. So what we do is we say equals to new car. Did you see that? Then we open bracket and close bracket. And in between this bracket, you remember when we were creating the car class, we told it that it will be expecting a make, a model, and a year. And immediately we open and close this bracket. You see, VS Code is telling us we are to pass a make, a model, and yeah. So let's pass the make of this car to be Toyota, of course. Toyota. And the next thing is the model. Let's say this is Camry. And the year is 2024. Now, by doing this now, you have created what we call an instance of this car, or an object of this car class. This class is the plan. This that Toyota now that we just created is the object. Now, see the fun part of it. If I come down now and I say console.log and I say Toyota dot, now we know any object we create from this car class, we have a make, it will have a model, and it will have a year. So I'll just say Toyota dot, let me say I just want to print out the make. Let me run this in the terminal and let's see what happens. Okay, oh, I need to save, Ctrl S. Let me turn on auto save. Where is auto save? So auto save, if you don't know what that does, that will just auto save your code. So whenever you edit, you don't have to be doing Ctrl S again. I only do that when I'm writing JavaScript. I hate it when I'm doing React or Vue.js, because any small thing you write, it will auto save it. Boom. Did you see? We get the make to be Toyota, which is actually the make we passed in. Let's try to print out the year. If we go ahead and print out the year now, you see it says 2004. So using this approach now, we've been able to create a plan. This right here is the plan, or we call it the blueprint for creating a car. And this right here is the actual object, is the actual car object. Now, don't forget, when we are creating the object, we had to use the new keyword. What that new keyword is telling it is that, hey, I'm creating a new instance. Keep in mind, I am creating a new instance or a new object of type car, which means, you know, that car plan I drew earlier, I wrote for you this car plan. Good. I want to create an object of that plan now. That is why we use the new keyword here. Now, when you use the new keyword, you notice we are passing in 3 arguments to it. Because if you look at this constructor we created here, a constructor in a class is just a function in the class. But we call it a constructor because it has a special role it plays in the class. And that's what I'm about to explain. Now, when we created the new instance of the car, we passed in 3 arguments. Now, if you look at the constructor of this car class, it's expecting 3 arguments also: a make, a model, and a year. Now, immediately we pass in these 3 arguments, the constructor will take up the job of setting the values we pass here into the properties of the object we are creating. So as we are creating a Toyota object now, this constructor we have here will set the make of the Toyota to be whatever make we pass. The make of the object to be whatever make we pass. It will set the model to be whatever model we pass. And it will set the year to be whatever year we passed. And that is what this keyword is referring to. This keyword here is referring to the object we are creating at that point in time. So when you see this keyword, it's talking about that object you want to create. So it's basically saying, you know what, this dot make, which means Toyota that I am creating right now, sets the make sets the make to whatever make is passed to you, sets the model to whatever model is passed to you, and sets the year to whatever year is passed to you. That is what the this keyword is referring to. The this keyword is referring to the new object you are creating. And that is because when you have a plan like this, like I said, imagine if I build a house in Lagos now following a blueprint. Nothing stops me from taking the blueprint to Abuja and building another house with that blueprint. Nothing stops me from taking it to another state and building another house with that blueprint. So because when you create a car class, okay, you can create as many objects as possible from that class. Look at this. Let's create a new car called Ford. So I can say const Ford equals to new car. And then in this new car again now, I have to pass these three properties to it. So, oh, S is missing here. So here now, I can say the make will be Ford. The model, I don't really know any common model of Ford. Anyone that has one. If you know any model of Ford, else I'll throw in anything there. Let's just call it, let's give a new model to it. Let's say this is, I can't think of a model. Anyone help us? Venza, right? Okay, good. And good, let's go with Venza. That's the model. And the year, let's say 2010. That's the year of the car. Now, by doing this, you know, give us a model of Ford then. Give us a model. Edge. Like edge
Ford
like
edge.
this. Edge like this.
Ford edge, yes.
And let's
yes.
go with that. But I still like the Venza too. We'll give it to whatever we want. All right. So now, if you look at what we have here now, we just created two objects. Somebody asked, okay, somebody told us Explorer, okay. Hans Knight, you can ask your question, but because of time, let me quickly finish explaining this. And so you don't forget, you can drop your questions in the comment section, okay, to make it easier that way. Drop it in the comment section. Immediately I'm done explaining this, I'll come back to the comment section to read the questions. All right. Now, if you look at what we have here now, we have just created two objects, two cars following this plan here. And because of that, you will notice that all the car we created would always have all of these properties, would always have all of those properties. Now, let's talk about this constructor method. I know I've talked about it, but let's talk about it again. Now, the constructor method, like I told you, is a special method, okay? It has to have the exact name constructor. You can't change it. It has to have that name. It is executed automatically when a new object is created. You know, for those of you that were in the last class, when we talked about functions and methods in JavaScript, I told you that a function would only execute when it is called, when it is invoked. But you see this constructor function, it will automatically be called when you use the new keyword. So immediately you create a new object of that class, the constructor function will be called. Lastly, it is used to initialize all the object properties. You see all the properties of the object. It is inside this constructor that we are initializing all of them. Okay? Now, let's talk about methods. Initially, when we were talking about OOP, okay, one thing we have looked at is that all objects, okay, all objects has properties. We've talked about this. And we also said that all objects has actions or methods. Now, we've just looked at how to give properties to a class. But how about giving it actions? Okay, so how do we add methods to a class? It's very simple. Immediately after this constructor, just come down and write your functions. So let's say a car, this car we are building, let's say we will put it will have a special function of self-driving, so it can drive by itself. So let's say self-drive. That is the function there. So we write it as a function and we open this like this, or we put it in auto drive. I think auto drive is a more fun name than self-drive. Let's say auto drive. And then in this function now, all we want to do is we want to call the brand of the car. We just want to do a console.log we want to call the name. So we'll say, for example, if Camry is the one self-driving, we'll say Camry is self-driving. So to do that, we want to get access. We want to get access to the name, to the model of the car. So to get access to it, we'll just say this dot model, okay? Then we'll do a plus is auto driving. Let's put a space here. So we have the space and save this now. Now, we've created two cars. We've created the Toyota car. We've created the Ford car. Now, let's go ahead now. Okay, let's go ahead now and do Toyota dot self auto drive. If I call this function and run this, let's see what we get. Let me close this so we have more space. Do you see? It says Camry is auto driving. What if we want Ford to auto drive? We'll just say Ford dot auto drive. And if we run this again now, Camry is auto driving, Edge is auto driving. So now, although these two objects were created from this class, they behave differently. Just like how have you ever, if you've met some twin before, you see some twin that are totally just different. Okay, they are twins, so even as human beings. Because if you want to think about it, since all of us are similar, we have hair, we have mouth, we have nose, why are we not acting the same? Because even though we are all from the same class, we just have some of our properties varies. For example, now my hair color is different from somebody's hair color. You would see some people that their legs are longer, some people are taller. Fine, we are made from the same class does not mean that all of our property values must be the same. And that is why you see that, yes, we created these two cars from the same class of car, but they still behave independently. When you say Toyota.drive, Toyota will not start coming to drive Ford. And when you say Ford.drive, it will not come and start driving Toyota. They are different objects created from the same class. So Salams asked a question. He says, is it compulsory to create a user-defined constructor? Yes, if you're creating a class, if you're going to use a class, you have to have a constructor. It's just how it is. You have to have a constructor there. All right, you have to have a constructor there. So that is how you add methods to your class. That is how you add methods to your class. Now, is it possible for your methods to have parameters? Yes. If you're in our last class, when we talked about methods having parameters, you saw that in action. So you can come here now if you want to create a parameter. If you want your method to get a parameter, you just have to create it to collect the parameter. So in other sense, what I mean is this. Let's say our car can speed. Okay, our car can speed, but when speeding, we want to be able to pass in the speed level. So we'll tell it to expect speed level, double E level. Okay, and then all we want to do is we'll just do a console.log. If we have enough time, we might actually build a project together, combining what we learned from the last class and today to actually make it, because I've discovered one of the problems with all this learning all these programming terms is not actually implementing it. So that has always been a problem. So let's look at this now. So I'll say this dot, let's call the model, this dot model, then plus is speeding. Okay, so this dot model plus is speeding at, then we want to add the speed level. So we'll say speed level. So let's go ahead and copy this. I don't know why it's not auto-completing for me. It's speeding at plus speed level. It's because we've not learned about, if you look at, we're supposed to look at string interpolation or template literals in the last class. It's because we've not looked at template literal. That's why I'm doing all this plus. I personally hate doing this. It looks so everywhere. But we'll look at template literal and we'll come back to fix this. All this plus plus, we can get rid of it using template literal. So for now, we'll just say
you can actually use it so that when you are explaining it.
Yeah, we'll do that. Let me just do this. Let me just do this first. Once I'm done with that, we'll look at template literal. So this dot model plus is speeding at, we'll plus the speed level, then we'll just say per hour. Per hour. Let's spell that correctly. Now watch this. Let me comment out this part. I can say Toyota. You know, Toyota is an object we created from our car class. So I can say Toyota dot speed. You know, according to speed, the speed method, we are supposed to pass in a speed level to it. So let's say we want to speed at 80 miles per hour. So we'll pass 80 to it. If we go ahead and run this now, you see, it says Camry is speeding at 80, oh, we did not put miles there, 80 miles per hour. Let's do that there. Save that. Let's rerun this. Good. Camry is speeding at 80 miles per hour. So you can actually pass parameters to your class methods too. You can do that if you want to. Now, classes, this concept of classes is supported amongst most modern browsers. It's supported everywhere. So you don't have to be because that's one thing you need to look at when you are coding in JavaScript. You don't implement concepts that are not supported by most browsers. But browsers since the year 2015 up have been supporting the concept of classes. So I guess it's safe to say you can use it. So let's quickly talk about template literals before we continue on classes. Let's quickly talk about template literals.
Sorry, boss. I couldn't get to put a chat. Why are we using this? I'm new. Please.
Why do we need to use this?
Yes.
Okay, you joined us from the beginning of the class, right?
No.
Okay.
I just got this on that report.
Okay. Now the breakdown I can give you is this. When you follow object-oriented programming approach, it leads to you writing cleaner and more maintainable code. Now, if you know, earlier I showed you an example of if you create an object without using the this OOP approach. You know, I showed you that we can do that. I can just simply say create an object of const. Let's say this will be a which other popular car brand? We've written Toyota, Ford. Let's go with which other popular brand? Why are they all running from my head now that I need them? Okay, somebody said it.
Mercedes-Benz.
Okay, let's say Benz. Okay, let's say Benz. Okay, equal to. You can do like this. Then give it a make, right?
Are you Benzman?
Give it a make. So the make will be BMW. Give it a model. Give us a model. And a year. Let's say the year is 2006.
One night.
Eh? You know what?
The one with the video buy 2 days ago.
Let's go with BMW. I don't know of this model, but I'm just going to throw something there. So these are now to answer your question for what's his name that asked the question, I think Kings. To answer your question, why are we not using this approach, right? Now, most coding or most code you will see, okay, most of the times that I know is most of them use this approach. Now, the problem, there is really not too much problem with this. You can write your code with this and it works. But don't forget the main reason for the class is we want to look at classes in JavaScript. That is what I am trying to explain. Now, as for why would I pick this approach, okay, this approach over this, I think it has to do with majorly because of my experience. I've coded to the point that I know when I use object-oriented programming approach, I get cleaner code, I write way more maintainable code. So because of that, I would always go with that approach. Now, like I said, JavaScript is the only language I have dealt with that you can create an object like this, and it will still recognize it as an object without creating it from a class. Okay, most other programming languages like C#, Python, Java, C++, you have to create a class first before you can create an object of the class. That being said, using this approach, okay, is prone to errors like, for example, as you created a Benz here, you might want to create another one, okay, and you forget to give it, let's call this Benz 2, and you forget to give it a model. We've talked about this before. Now, if you look at this is an object, this is an object. But if you look at the properties of this object, this one is missing a model, this one is not. And let's say when you were writing it, you thought you gave it a model, and then you come down now and you try to do Benz2 dot model, and you try to print this out. So you do a console.log, you paste that there. Let me go ahead and comment out the other sections of our code. If I save this now, okay, if I save that now and run this, you see it gives me undefined. That's an error there. Why? Because this Benz here does not have a model. Are we together? This Benz here does not have a model. Now, let me show you how this other approach now fixes this. Because we have a constructor that is expecting 3 parameters, whenever you forget to pass one during your code, it will warn you already that you're missing a parameter that you were supposed to pass, or an argument in this case. You are missing something. But you see this one would not tell you. It is at runtime that your code will detect that something is wrong and it will break. And believe me, when you are coding, it's better for your code to have issues when you are coding than when your users are using it. Are we together? If we use this approach now, what this approach will do is it will make it impossible for a user to be able to create a car without passing the 3 properties. But if you use this approach right here, there is no rule. There's nothing stopping somebody from creating a car without a model. In fact, we just did. Are we together? Now, most people that uses classes, I know why some of us like, this is foreign. Would I ever use this? If you want to grow to the level where you want to start working on frameworks or libraries, that's when you understand that this approach really comes in handy, because you want to protect your code. You want to force your users to supply all of the properties of a particular object before they can create an object. So that is where this would mostly come in handy. But like I said, object-oriented programming is actually a really big topic that we can't really cover everything today. But when you're using object-oriented programming approach, you tend to write way cleaner and more maintainable code as opposed to this one here. Are we together? Let me give you an example. Let's say for every car we create, right? For every car we create, we want to have a description of the car. Okay, for every car we create now, we want to have a property called description. Okay, now this description will be, we want to combine the make of the car with the model of the car to give a description. So we want the description to be something like this dot make plus space this dot model. So this dot make plus this dot model. Let me delete this. Now, if I come here and I do Benz dot description, if I run this, Okay, it says on the, oh, we can't really do that there. We have to do it inside a method. That's my bad. This has to be a method. Let's call this method let's call it do something. Okay, let's call this method do something, and its job, this will be a function. This will be a function. So we'll make this a function, and this function will just return. We talked about the return keyword in the last class too. For those of you that missed it, I advise you go back to watch that. And we'll just return this dot make this dot model. So here now, if I do Benz, if I call Benz dot do something, and I run this now, you see it prints this out. But look at the problem we have here now. If I want to create another Benz, I would answer your question, Salam. I'm seeing your questions. I would answer it once I'm done explaining this. Now, the problem with this thing, this approach, or an issue I'm already seeing using this approach with this example I did is this. Let's say we want to create another Benz. So we come here and we say const Benz. Let's call this Benz 2 again, equal to, we use this approach. Now, you will notice that if we give the same properties, so let's have a model, colon, we'll specify the model to be, this time, let's still go with, let's go with Ford again. No, not the, is the make that should be Ford, not the model. So the make will be Ford. The model will be, let's go with the Venza. This somebody gave us, I don't care if it's a type. Let's just put something there. The year, let's say 2004. Now, watch this. Did you notice that to create this new object, I had to rewrite all of this thing again? I had to specify that this is for model, this is for make, this is for model, this is for year. In fact, this function now, I have to rewrite it inside this new object again. Did you see that? So I had to rewrite the function again all over. Now, imagine if we are going to have about 5 different functions. What this means is that for every object I create like this, I have to rewrite the function over and over and over and over again, which means at the end of the day, 5 times, let's say we have 5 functions, as we have do something here. Let's say we have to have another function called move. Okay, let's say we want to have another function called move. I have to come here and say function. I have to come and say function move, and then we'll just do a, what am I, oh, we need a comma there. Okay, function move. I'll do console.log. We'll do a this.model plus is moving. Now look at this. If I make another Benz, I have to repeat this code inside the new object again. Did you see that? If I add another function to this Benz, okay, let's actually call this Benz 1. So we can refer to them as Benz 1, Benz 2. If I had another function to Benz 1 again, I have to go and write it inside Benz 2. So imagine you have about 20 Benzes as your object. So now, right now, we have 2 objects here, Benz 1, Benz 2. If I have 20, I have to copy all of these functions inside 20 of them. Now, imagine, keep that in mind. Let's go back to this approach we use. When I created this car, it was there I wrote auto drive and speed, right? When I created instances of the car, did I have to write the code for the functions again? Kings, you were the one that asked this question. I don't know if you're getting anything from what I'm explaining.
No. Yeah, I'm getting it.
Are you getting the point I'm trying to make?
Yes.
So if you use this approach, you have to virtually write all of the method and all of the methods every time for each new object you create. But if you use this approach now, because all of them are made from the same class, they can use the method that is available in the class. Hence, you're making your work easy. Are we together?
Yes.
And the good thing, another thing I pointed out that I want to make clear out is, if you use this approach again, there's tendency of forgetting one thing. It's always there. I've had an error in my code where comma stressed me out from 3 p.m. to around 3 p.m. in the afternoon to around 8 p.m. in the evening. I was searching Google for errors that did not exist. I came back to my code and I saw it was a comma. So errors can occur in your code. And one thing I'll tell you as a developer is, you need to start writing code that are easily maintainable and easily maintainable, code that is clean and easy for you to read. If you have functions flying everywhere in your different objects, when you modify one of the functions, for example, now let's go back to what I had before. In this do something, we were returning this dot make plus this dot model. Let's say we also want to add we also want to plus the year with it. So I'll do this dot year. Now, this new change I made here, I have to go to all the objects and make the change. So that means I have to come down here, make the change. If I have 5 more, I have to go to each and every one of them and make the change. But if I had just used this approach, all I need to do is make the change on one line of code, and it will affect all the objects that are created from that class. And that is why I said it helps you write codes that is easily maintainable, and it gives you clean code. You will not have a headache over something like this. But when you have methods flying everywhere inside all your objects, well, you're prone to have headaches. Do you catch the flow?
Yes, thank you.
All right. All right. So somebody else asked a question. Is it not compulsory to use function keyword when declaring or creating a function or a method in JS? It's not compulsory. I think you missed the last class. That's why you're asking this. But Salam, is this your first class with us?
Yes, sir.
All right, and we'll forgive you. We'll forgive you for today. Those that attended the last class already knows that.
Okay, thank you, sir.
All right. So in JavaScript, we have functions that are called nameless functions. Those functions don't have a name. We also have functions that you don't have to use the function keyword to define. Example of those functions are like the arrow functions. Now, when you are creating a function inside a class like this, inside an object like this, you have two options. You can use the function keyword like I'm saying here, or you use the arrow function approach. This would also work. Okay, this would also work. Now, for a class, when you have a class and you're creating a function, you can still use the function keyword if you want to, but you can also use this approach, because at runtime, JavaScript will tie each of these functions to their object. So it will end up looking like this. And that is why you notice I am not putting the function keyword there. In fact, it gives an error when you do that. Okay, you don't need to do it when you are using the object, when you're declaring the class. It is when you're using this other approach here now that you have to be doing function, or you use the arrow syntax here, whichever one you use. But when you're declaring a class, you don't need to use the function keyword. So I think the answer to that your question would be it depends. So I can't say no, I can't say yes, but it is not always compulsory to use the function keyword. There are approaches you will use that you must use it. There are approaches you will use that you don't have to use it. For example, if you want to write an arrow function now, it's not a must to use the function keyword. Okay? All right. Any other question? No question. All right. If you have question, go ahead and throw it in the comment section. Oh, Ellen was giving us a BMW, Range Rover, okay, BMW, Benz BMW. All right. When we need that, we'll use it again. So as I was saying, when you use the object-oriented programming approach, you tend to write cleaner code, more maintainable code. Although I know it's not easy for beginners to flow along with it, but believe me, it will make your coding journey a lot easier. Now, I know the one practice with JavaScript is everybody is used to this approach. Mostly if you are doing React, Vue.js, even personally, most times I use this approach too. Unless when I need to create multiple objects at a time, that's when I'll run to this approach, because I want to avoid writing all the methods over and over again. And that is something. If you know you are going to create multiple objects of the same type, just go and create a class for it and create instances of that class. So you don't have to be writing everything. Just imagine to create a new object now of the car class. All you need to do is say new car, pass the properties, boom, you are done. But to create an object like this, every time you have to create a new variable, set it equal to the curly bracelet, define all of the properties, and you define all of the methods. So if you need 20 of this, you need to repeat this 20 times. Which do you prefer, to write all of this 20 times or to repeat this 20 times? Of course, I'll go with this. Like I said, I'm lazy when it comes to coding. If you've got any question or contribution, please feel free to share with us. If there is none, then we can actually move ahead and talk about, should we talk about inheritance? Yeah, let's talk about inheritance, because I want today's class to expose you to object-oriented programming in JavaScript. So let's talk about inheritance in JavaScript. All right.
Let's talk about temporary literal before the question we have.
You said what? Template literal. Oh, that's true. Let's quickly look at template literals. It's not really a big topic. It is just a way. Now, if you look at this code I have here, right? This thing, what am I doing here? I'm concatenating two strings together, right? So the model is actually a string, and I'm doing plus another string. Now, template literals can really come in handy when template literal can, oh, Emmanuel, you said you prefer to write 20 times. Safe journey to you. All right. So template literals can really come in handy when you have a lot of values or variables that you want to concatenate. You see all these plus. When they are too much, it can really start getting confusing. Look at this now. Look at all the plus we are doing. So what we can do with template literal is actually simplify it. To make it understandable, I'll comment out this code. Let me create about 2 or 3 variables. So let's create a variable. Let's call it var. No, I hate using the var keyword. Go with const name equal to, let's set this equals to Sarah. No, yeah, let's go with Sarah. Or let me use somebody's name here. Bello is here. He was the first to join the class, so I'll go with his name. Const name equals to Bello, and const profession. Let's say Bello is a developer. And then, it should be in a string. You see why I don't like JavaScript? It took developer as if nothing is wrong. It's when you run the program now, it will shout on you. Programming languages like C# and Java would immediately shout that what are you writing there? Okay, so profession equals to developer. Now, let's say we want to greet Bello. So we want to say console.log Bello. Okay, instead of saying Bello, we'll do a plus name. Sorry, not plus. Name equals to Bello is a plus. Oh, is that's equals to not plus. Bello is a plus. We want to put his profession there. So we'll do plus profession. So Bello is a dash profession. Let's just go with that. If I run this now, you see it says Bello is a developer. But you notice all of the concatenation I'm doing here. Look at another way we could have pieced this using string literal. I could say console.log, and then I will create, now to create a string literal in JavaScript, we use the backtick sign. Backticks is that sign just on top of your tab. That sign on top of your tab. You know, after you have that, let me see if I can get my on-screen keyboard out. On-screen keyboard, let me see if I can bring it out. All right, perfect. This is your backticks. So if you look at your keyboard, look for this key there. This is how you create the backticks, but you have to hold your shifts down, okay, to create the backticks. That is what we use for template literal. So what you want to do to create a backtick is hold your shifts down and press that. No, you don't need to hold shift. If you hold shift, it will create this other symbol there. You don't need shift. So just press the key. It will create this for you. It looks like quotation mark, but it's not really quotation mark. You know, to make a string in any programming language, you use quotation mark. This one looks like quotation mark, but it's not. You see, the fun thing about using backticks is, inside this backticks, you can write your string or even write a JavaScript expression. You can call a variable and it will answer. So now what we wanted to do is, Bello is a developer, right? I can just come here and do this. I'll just create a template literal here. So I'll just do this. Now, you do this when you want to write a JavaScript expression. So I'll just come here and say name is a, create another one. And inside this one is where we want to have profession. Did you see this? Did you notice the difference between this and this now? In this approach, I'm not worried about the unnecessary plus signs or creating empty spaces. When you use this approach, you just write it as if you are writing a regular string. But whenever you want to insert a JavaScript expression, you use the $, curly bracelet open, curly bracelet close, put the JavaScript expression in there. And if we run this now, you see both of them still works. So normally what I do is whenever I want to have concatenate a lot of strings and JavaScript expression together, I just go with this approach because it feels more natural for me. Instead of breaking each string and putting the plus sign there, you just write everything together, but you specify that this is a JavaScript expression by putting it inside $, curly bracelet close, then you put the expression in there. This is the template literal I was referring to here. So to fix this our code now, all those places we add all the string concatenation, like this place now, we can use a template literal. Although this is simpler though than a template literal. Let me just give you this. Some of these things you learn in programming, it's not as if you start using it everywhere. Sometimes they are convenient and better to use. Sometimes it's an overkill. What I mean is this. If you look at this now, we are just concatenating two strings. I prefer this than doing this because it's just two. It's simple, it's readable, mostly for a beginner. But you see, when I start getting more than 1, 2, 3, that is where I prefer to implement template literal. So I'll change this to a template literal. And to do that, surround everything with a backticks. Get rid of all of the quotation marks and plus. Whenever you have a JavaScript expression, you want to do $, quotation mark, put the expression there. Get rid of the plus and question mark again. This is another JavaScript expression. I'll put $, quotation mark, paste this here. You see this now? This thing I have here is what I just replaced with this template literal here. And it's actually cleaner. But like I said, it's not everywhere you throw template literal to. Sometimes it's better to use it. Sometimes it's an overkill. It's too much. Sometimes you just go with a simpler one like this. All right? Okay. Thank you for being so explicit. I read this template literal. I didn't get it up to you now. Well, that's the reason for the class. So thanks for acknowledging that there. So that's just what template literal is. Some other programming languages have it, like C#, but they call it string interpolation there. Java also has it, I think, string interpolation. So this template literal is just a sweeter way. Let me call it a sweeter or better, a more professional, more like a show-off way of concatenating string. That is just what it is. But when you're writing the string, when you need to write a JavaScript expression, write your $, open curly bracelet, close it, put the JavaScript expression there. Else, by default, anything inside the template literal is treated as a string. So you need to specify that, hey, this is not a string. this is a variable I want to call here. This one here is not also a string. This is a variable I want to call. That is just what that does for us. All right, with that being said, let's talk about inheritance. Let's talk about inheritance. All right, perfect. Let me go ahead. Now, I will use another concept to explain this concept of inheritance so that we get it more. Let me see. Should I use another concept? No, let's go with this car concept we have been dealing with. Okay, let's go with this car concept. Now, if we go back to this our class, if you remember what we have here, let me get rid of the methods. We don't need them for now. We can use it as plain as it. Oh, let's go ahead and leave the methods. Now, we want to talk about inheritance in classes in JavaScript. When you deal with the term inheritance in programming, the first thing I like doing, let me tell you guys this. This is what, okay, Emmanuel says template literals are syntactic sugar. That was the word I was looking for. So inheritance, one thing I do is this. For those of you that are still getting started with programming, or even if you are a pro, this is the tip I can give you. What makes these topics easy for me to know and remember is that whenever I'm learning them, I try to relate them with real life scenario. That way, when I forget it, I can use the real life scenario to like remember what it means. So we want to talk about inheritance right now. Outside this class, what do you understand by inheritance? It's just more like, let's give a rough example. A father gives birth to children. By default, all of the children inherit what belongs to the father. Taking ownership. Thank you, Rukayat, for that. Taking ownership. That is just roughly what inheritance means. Now, there are some things you will note in terms of inheritance. The fact that a son inherited properties from the father does not stop the son from having his own properties. The son can have his own properties, he just has more by inheriting from the father. What I'm trying to point out is this. Sometimes when you look at objects in real life, you will discover that sometimes we need to inherit these objects once in a while. What I mean is this. Now, a class created with a class inherit, okay? Now, when you have a class, for example, now we have this class car, right? Let's say we want to create another class, but that class would have all of these properties too. It will have a make, a model, and a year. So let's say we want to create a class of, let me guess, a class called model. So these are, you know what? I think to explain this, let's use a totally different thing. I want to use examples that will make more sense to us. Instead of using this example, I don't feel this will clean it up for us well. Let's create an animal class. So let's create a class called animal. Now, how do we create a class? This is how you create it. Class animal. Then you put a constructor for the class. And this animal class, let's say all animals, what are the common properties we know are common to an animal? Help me out here. Common properties of an animal. Color. Yeah. Animals would have a skin. So we can say skin color. Let me see. I want to try to use an example that will really explain this deep down. I don't want to scatter all of the examples.
Animals, they have.
Okay, wait. Let me see this. Okay. Okay. I think earlier on, some of you can remember I made mention of a car. If you think of a car very well, you can look at it to be a type of a vehicle, right? Who remember I said that? You can look at a car to be a type of a vehicle. You can look at an under vehicle. You can have different types of vehicles. A car can be a vehicle, a truck, a lorry, and so on. So instead of going that approach, let's have a class called vehicle. Okay. Now, this class would have, now all vehicles like we know will have the make, which is the manufacturer. They'll have a model and they'll have the year they were made. Are we together? So instead of having this inside a car, let's move it to the vehicle. And then all vehicles, for now, let's get rid of the methods. We don't want to deal with the methods. Now, these are vehicles. Now, let's say after having this class called vehicle, we want to have a car called class called car. But we now thought about it. But a car is a type of a vehicle now. So instead of us to repeat all of these things we have here, normally before this was what we did, right? Now, instead of repeating this, we can use the concept of inheritance to make a car inherit from a vehicle. How do we do that in JavaScript? Well, what you need to do is whenever you want to define the car, all you need to do is give it a keyword called extends. Oh, X there. What am I spelling that wrong? Extend. X. All right, good. It's called extends. So all we need to do is specify that this class, extends, the name before the extends, class car extends vehicle. This is what we need to do. By doing this now, automatically, this constructor we have here is basically copied, but you actually need to copy it. You need to copy it for it to actually work. For it to work, inside the constructor of this class car now, we don't need to specify the model, the make, and the year anymore. All we need to do is tell it that it should inherit, it should refer to the super class, and then we'll pass all of this to it. Just like this. Now, by doing this now, what we are basically saying is that this car extends the vehicle class, and which means whatever is available in the vehicle class, the car class can have it. So let's give this vehicle class some methods. Let's give it a method like move. Let's give it a method like move. And in this method now, we'll just do a console.log this dot model plus is moving. Let's just go with this. Let's save this now. Perfect. Now, if you take note of what we have done, if you look at this code, you will notice that I did not repeat the move method inside this car class, right? The only thing I'm doing in this car class now is I'm extending from the vehicle class, and then inside the constructor, I am specifying that it should pass all of the make, model, and year to this super here. This super keyword is referring to the vehicle. That is the class is extending, is inheriting from. So this super here is referring to the constructor of the vehicle class. So this thing we are repeating here like this is talking to this constructor. Now, what this enables us to do is this. Look at this magic. I can come here now and create an object of the car class. So I can come here and say const Ford equal to new car. Now, the moment I say new car and I open and close curly bracelets, now this car class now, we can pass all of this model, all of this data to it. So let's go ahead and pass it the make as Ford, comma, the model as Edge, and the year as 2004. Watch this. I can come down and say Ford dot. Did you see I'm seeing the move method? Did you guys see this? Are you noticing the move there? But if you look at the code, there was no move there. So where is the move coming from? It is via inheritance. Because this car class now is extending the vehicle class, it now makes it possible. It now makes it possible for us now to be able to it gives us access to everything the vehicle class has. So here now I can say Ford dot move, and if I run this code, I get an error. What's the error saying? Make is not defined. Make is not defined. Why is it giving me that error? Where is the error coming from? I already said this dot make Is it make or model? Why is it giving error of make? Let me see what is happening there. Okay, create the constructor, pass in the brand. Okay, what am I doing wrong? What am I doing wrong? What am I doing wrong?
What you are doing wrong is what you console log is model, not make.
Let me see.
What you are console logging.
No, even if it was make, if it was model, I don't expect an error there. I'm actually something, you see, still give the same error. Something is wrong, and that is why it's not working. What is wrong? What is wrong? What is wrong? Let me see. Dot move. Okay, let's look at it. It says make is not defined. Oh, yes. Oof, I know where the error is coming from. All of these are supposed to also be in the constructor. That is where it's coming from. Yeah, we have to define it in the constructor, and that is because we don't. If you don't have
I think you need to reshare your screen, sir.
Did I
It's
disconnect?
frozen here.
Oh. Okay, can you see it now? Can you guys see my screen now? Hello, can you see my screen now? Hello, guys, can you see my screen?
It's frozen.
Yeah, but I...
Go on, listen.
Okay, sorry about
Try to
that.
scroll up, sir. Try to scroll up.
Can you see it now?
It's still the same.
All right, you know what? Let me disconnect and reconnect. Before the network issue started, we were having an error, and I think I tried fixing it, and I guess fine, it's working now. Let me quickly explain what caused the error. This is it. Whenever you're creating a constructor, you always want to specify all the parameters that you'll be passing to the constructor. My mistake was this: I did not specify it, and then I now called the super class, and I was passing it make, model, and year. So JavaScript was like, where are these three things coming from? Okay, so you have to specify them here. So by doing this make will be passed here, this model will be passed here, the year will be passed here. That is all you need to do for the constructor, and you can see this code is working now. But we have not actually looked at how inheritance can actually be beneficial to us, or why we need it. What we have seen so far is that with inheritance, we can have one class with the main functionalities, and we have other classes we refer to as derived classes. Some people call this the base class. You can call it the derived class or the subclass. This class right here is inheriting from the vehicle class, and the only thing it's doing now is passing the make, model, and year to the vehicle class. But watch what happens when we want to create another type of a vehicle. I can come here and say class, let's call this truck. Of course, it will also go ahead and extend vehicle, and we'll just have to replicate the same thing. So we need a constructor. Each truck now we have a make. Let me just go ahead and copy this because that's exactly what we have. So we'll copy this. Perfect. Did you see now that we have two classes, the truck class and the car class, that is inheriting from the vehicle class? And all these two classes need to do is set their constructor and pass the parameters to the super class. This is the super class here. The class this class is extending is the super class. All it needs to do is pass the parameter to the super class, and the super class will take charge of the rest of the thing. Now, you notice that this move class here is only available in this vehicle class, but you will note that both car and truck can have access to it. So I can come here now and say const truck equals to new truck, and this truck now we are going to give it let's say the make is Innoson. I don't know if they make truck, but let's just see. And the model will be BX 2019. Since most of their car are latest class cars, let's just go with that. BS 2019, and the year.
We have variety of trucks. You know, we have variety of trucks.
And that's why we are just giving a random model. I'm not really concerned with if it's correct or not. I just need to explain my point. And you will notice that I can come here now and say truck dot move. Did you notice that? And if we run this again now, you see that Ford is moving in Innocent, which is the name. Is it the make we're saying there? Let's do model, not make. Model. So let's rerun this. Edge is moving. BX 2019 is also moving. So what I'm trying to point out here is this. You notice that the car class and the truck class are both inheriting. That is, they are both extending the vehicle class. And because they are extending it, they have access to the methods that are available in this class. Look at another fun part of this. These classes now can go on and have their own implementation. Let me say a car now. We know that a car used to have like 4 doors. So we can say this car, or what is common to a car that is different from a vehicle? I need something that is obvious. Anything obvious, I mean, between a car and a truck, the height. Okay, both of them can still have height. You know what? Let me just go ahead and throw in something. Let's say
Tire. Numbers of tires.
Numbers of tires. But I need something that, okay, let's just use a method in this case. Let's say this car now can auto drive. Let's go with auto drive. Did you see that? And then we'll just do a console.log. We'll do a console.log. This, let's do, okay, is it my network? Mason, I'm here. Stop using my class to whine people. Mason. Mason,
that kind of JavaScript.
stop using my class to... Hello, Mason.
This stuck.
Can you guys hear?
Stop.
Can you guys hear me?
Mr. Steven, you're breaking.
Yeah, I know.
Can't hear
It's
you.
my network from here. So sorry about that. How about now? Is it better now?
It's better, but missed what you said the last time.
I'll repeat it. Don't worry. So now, if you look at this car class now, I'm writing the auto drive method there. And this auto drive is just going to say this car, let's make it a string. This car can auto drive. Or let's just say this car is on auto drive. Now, of course, we know that we don't want to put auto drive in vehicles. I mean, in trucks, you don't want to do that. If you start producing cars later, please leave auto drive away from trucks. So we'll come to this truck now. We want to give it a different method. Maybe this truck, because of its size, it has a which other thing can trucks do that regular cars can't? You know what? We don't really need that. I can explain with the auto drive alone. Now watch this. Did you notice that both the car, the truck, and the car are both inheriting from the vehicle class? The vehicle class gives them the move method. Now, this move method is available to both the car class and the truck class. But you notice that the car class also went ahead and implemented a new method called auto drive. Now, this auto drive method would only be available to the car. It won't be available to the truck. Watch this. I can say Ford, you know, Ford was created using the car class. So we can say Ford.auto drive. But what happens when I try to do truck.auto drive and save this? Of course, JavaScript will let you write anything. It's at runtime you will meet the error. You see, we have an error. What is the error saying? It says truck.auto drive is not a function. That is because your truck does not implement the method, does not have a method called auto drive. The only one that has is the car class that has the method auto drive. Now, what this is trying to explain to you, if we go back to the example I gave, a father has a son, the son automatically inherits what the father has. But then the son can go on and have his or her own properties, his property in this case. But you know, sometimes a man might have two children. The two children can inherit properties from the father, but they can still go on to have their own individual properties that are only available to each and every one of them individually. So just like that, we have a vehicle class, which is the parent or the father class here. We call this the base class. And then this base class now is inherited by two subclasses, the car class and the truck class. Now, the truck class has its own auto drive. So it will inherit the move method from the parent, but also have its own auto drive. The truck class now also inherits the move method, but it does not have its own, it does not have any other method. Of course, it can have if you want it to, but this one does not have. And because of that now, it cannot have access to the auto drive. It's not going to say because it's also inherited from the vehicle class, it must have access to it. Of course, that's not possible. Do you guys get the point I'm trying to make here?
Yes, sir.
All right.
Yes.
So that is just what inheritance cover. Okay. Sometimes this is not just tied to methods alone. This constructor, this car now can have a new property. Let's call this new property color. Okay, this is a new property here. Now, if you note, the super class does not have a property called color for it. So you need to actually implement this by doing this dot color equal to color. You see this now? So we pass the new property color to this constructor here. I mean to the car constructor, and then it's going ahead to implement that. And then you see this vehicle does not have it too, which means on our car now, we can do Ford dot color. Let's print this out by doing, oops, we'll do a console dot log Ford dot color. And if we run this, let's get rid of this auto drive. We know it's not possible. If we run this now, you see, oh, we did not pass the color when we created the Ford. Look at, this was where we created Ford. We need to pass a color as a fourth parameter. Let's say it's black. That was why we got undefined. Whenever you get undefined in your code, it means you did not define the variable or you did not pass the parameter that you were supposed to pass. Let's run this again. You see, it prints black for us. But watch what happens when we try to do truck.color. Of course, we know our truck does not have a color property, but let's try to run this. We get undefined. It doesn't have. Even if you go ahead and pass a color, if you pass black here, this would even be worst. We should get an error in this case now. Let's save this, run this. You see, black is not defined. Oh, we should pass it as a property. I mean, as a string. We should still get our undefined. That's because if you look at the constructor for creating a truck, it does not provide it's not expecting a color to be passed in, so it did not implement it. But car was expecting a color to be passed in, and it implemented it. So basically, in a nutshell, what I'm trying to explain is this. You can have a parent class and children classes that inherit from the parent class. Now, when a child is extending its parent, is inheriting everything the parent has, both the method and the properties of the parents. Then each individual child now can go ahead and have its own implementation again that will make it different from other implementation. This same thing we are looking at here, you can look at it in the animal kingdom. So we can have a class called animal, then a class called dog. But if you think of this deeply self, you see that even the dogs, they have different breeds there. So the dog class can be a subclass again that we inherit from the animal class, and so on and so forth. So that is just a breakdown of OOP, at least the basis. Now, this is just a few hours class. I'm not expecting you become a guru in this, but my main target here is at least you learn enough to be able to at least watch a YouTube video and understand it well. Okay, if you've got questions, please go ahead and drop it in the comment section, and we can treat it, and I'll try to answer it. If you've got any contribution, please drop it too. Some people they always sabi pass me. Emmanuel, Elen, and co. All right. Ninth, you have a question. Please go ahead and ask. If you're in a quiet place, you can unmute your mic and ask.
Okay. Yeah, can you hear me now?
Yes.
Okay. Can another class
Inherit from car.
and that the car?
Is that your
Another
question?
class. Yeah, can another class, yes, inherit from car?
Yes, you can. But personally, with my own experience, I try to limit the level of inheritance so it doesn't get too deep. Okay, so I can create, let's say we want to have a class called Ford. Okay, I can make it extend car, and by default now, this class now will inherit everything from car and everything from vehicle. You get the gist now, just like your great grandparents. Are we together? Because if you look at this now,
Yes.
this Ford as a class is inheriting from car, which is its own direct parent class, and then car is inheriting from vehicle. So that makes vehicle the grandparent of what? The Ford car here. So it works that way too. So if we go ahead and create a constructor for this now, let's put a constructor here. Let's put a constructor. So this color has to be passed here. You will notice, since we have a constructor here now, let's create an instance of our Ford class. I can come here now and say const f, let's just call it f, equals to new Ford. And of course, this is expecting four arguments, so we'll pass the 4 like that. You will notice now I can do f dot move. You see that move works too. And if I execute this, you see edge is still moving. But don't forget that the move method is in the vehicle class, and the vehicle class is like the grandparent of the Ford class. So that is possible too. That is possible. If you've got any other question, please keep it in the comment section. Okay. All right. If you've got contributions, please feel free to share. Don't forget, I'm also here to learn too. Emmanuel, if you have 1 or 2 things to teach me, Mason and co. All right.
Okay, why you anyway, Ivan, you don't call Ivan at the agent.
All right. According to our course outline, the only thing we could not cover last class was ternary operator and the export and the ES model import and export. Because of time, I have another appointment by 12 and I might delay it a bit. But because of time, we might only be able to look at ternary operator. And I said we might build a project if we have time, but the time is already gone. This JavaScript, you guys, I don't really know. The truth is, there is no amount of classes we'd ever have that will be enough. Because I prefer we explaining, looking at one thing and understanding it than looking at everything and not understanding it. So let me see if we can quickly look at the ternary operator. For those of you that are just joining us for this class, we started this class last week. We looked at, these are all the topics we looked at in the last class. Today, we started looking at classes, template, literal. Let me see if we can cover ternary operator. All of these topics are the topics I advise you to learn and master to an extent before you go on to learn any front-end framework like Vue.js or React. Okay, Emmanuel says, Ninth, if you start writing OOP mostly in JavaScript, the inheritance will work if you want to inherit from another child element. But the best method is for you to tie everything using the static keyword because it makes it more readable. Yeah, that's true. And we can actually look at that today. This is what I advise. After this class, you guys, please try to go to W3 school. Read up their material on JavaScript classes. They covered what we have looked at so far and even a little bit more. Okay, so Alabi Sunday says, is it possible to print out the properties without accessing the property name? The answer to that is no. In fact, if you want to access the property of an object in JavaScript, you have to specify the name of the property. There are two ways you specify it. You either specify it using the dot operator, or you specify it passing the name, the property name as a string. I would explain that to you. So let me explain what I mean. If you want to print out the make of this car now, this Ford we created, you can either do Ford.make. This is one way. Or another way you can do it is you do F square bracket. You pretend as if you want to access an array. You remember in the last class when we treated arrays, I told you guys this is how you access items in an array. You can also use it for a property too. I mean for an object. But all you have to do is pass make like this. So either this way or this way. But it shall be one of them. Let's see if it works. So if I move this here, just copy and paste, move this. Let's do F dot make. Let me go ahead and save this. If I run this now, you see that it works. I did not get any error. That's a good sign. But let me go through that again. Let me rerun that. You see that it works. Ford. So you either use this approach or this approach. There is no other way, and you must supply it. So I guess that answers your question. And Emmanuel also tried answering your question. You can read it up there to get one or two things from what he said too. Oof. All right, let's look at template literal. And for JavaScript, you guys should know that today being the end of, saying today is the end of the class does not mean we will not have other classes. For those of you that have been with me for a long time, we've had more than 7-8 JavaScript classes. So after today, whenever I'm free, I might create another space for us to have another class. But I am actually going to be having another class either next week, but it's not going to be a JavaScript class. It will be for C#. My C# people have also been disturbing me too. So we are going to have for C#. Maybe after that, I can now make room for JavaScript again. But let's try to give other languages space too. Okay, we've been doing JavaScript. Let's do another language too. Okay, so let's quickly look at template literal, and we might call it a day after that. Now, after today's class, I might work out another class where we would build a JavaScript project. Okay, after today's class. But we might not be able to build today because, like I said, I have another appointment. And okay, somebody says, what about the Golang guys? When are you going to make out time for us? Emmanuel, are you trying to look for my trouble? I don't code in Golang. Okay, but what I can do for the Tech Leap community, what I can do is this. I actually have somebody who wants to teach you guys Django backend development with Python. So I might look for somebody who is good with Golang, but I don't code in Golang myself, so I can't teach it. Unless maybe if you can, Emmanuel, if you pay like 1.5 or maybe around 5, I feel go learn now, come back, teach only you. You're already making money now.
You might be coming down. Coming down.
I'm just saying my mind. Father, we'll see.
All right. Let's quickly look at ternary operator before we call it a day. Now,
Hi, Nicholas. Sorry for interrupting. Sorry.
All right, go ahead.
Hi, Nicholas.
Yes.
All right. Okay. You know what? For those of you that are not in the Tech Leap community, that is where most of our discussion takes place. I'll paste the link to the group. If you want to join, you can join. If you don't feel like, but the group is actually a free group for everybody. So feel free to join us there. I'll paste the link on our chat section. Yeah, the link is already pasted there. So please go ahead and just join. That's where I drop most of the info. All right, that being said, let's quickly look at the ternary operator. Okay, now for the ternary operator, it's just the ternary operator is what we call, which word will I use for it? Is just a syntactic sugar for the if operator, but you only use the ternary operator for the ternary operator can't really suit every scenario of the if operator. Let me show you what I mean. Let's say we have an if statement. First of all, let's create a variable called const num equals to 20, and we want to say if, const s is missing there, if num equals to 20, we want to go ahead and do console.log num is, or let's do if num is greater than or equal to 20, we'll say num is greater, okay, greater or equal to 20. Else we want to say num is smaller, so just copy this and paste it, and we'll say num is smaller. Now if you look at this code now, it's just a basic if and else statement. If I go ahead and run this now, and you come to the terminal, let's rerun. Good. You see it says num is greater than 20. Now when you have this type of if statement that is as simple as this, take note again, this if statement has just one line of code inside the code block. The else part also has just one line of code. Now when you have this kind of if statement that the code block just contains single line of code, this is where you can use the ternary operator. So like I said, the ternary operator is just a shorthand method for writing the if statement. Let me show you how it goes. I can come here and I'll say, to write a ternary operator, you actually store this. You know what? Okay, sorry, let's do this. Let's return, do we need to return? Let's create another variable called const result, okay, equal to, let's say const result equals to empty string, and instead of console.login here, okay, instead of console.login, we'll set result equal to whatever this is. So result equals to that. Let's do the same thing here. Result is equals to this. Now this is the same thing we have earlier. It's just that I'm not doing console.log. And then later we'll console.log result. Perfect. Now if you look at this if statement, we have just one line of code inside of it. One line. So to make this into a ternary operator, what I can do is this. You see this place we have const result. I can just say, you know what, let's create another variable and call it const result 2. I'll just set it equal to, now this is the ternary operator I'm going to write. Now to write a ternary operator, there's a syntax to writing it. Okay, there's a syntax when you want to write the ternary operator. The syntax is this. You put the condition, okay, after the condition, you have a question mark. After that, you put what should happen if the condition is true. So, statement if true. So that's what you want to put there. Statement if true. Then you have a semicolon followed by statement if false. So you put the statement if it is true followed by the statement if it is false. Now, let me explain what we are doing here for those of you that don't get it. This thing that I'm writing here is just the syntax for the ternary operator. Nothing more, nothing less. Now, and I told you that the ternary operator is just a shorthand code, a shorthand way of writing the if statement. If you look at this if statement now, where is the condition? This is the condition, right? When num is less than or equal to 20. So copy that condition, replace it here. That's the condition. The next thing is the question mark, leave that the way it is. The next thing is what should happen if the statement is true. This is what we want to do if it is true, right? So we'll just do copy this, put it here. And then what should happen if the statement is false? We want to set result equals to this. So we put this here. So basically, this is how this is going to run. When JavaScript gets to this line of code, it will look at this condition. Is num greater than or equal to 20? What do we think is the answer to that? Who can help us out? Is num greater than or equals to 20? Look at the value of num before you answer. Num is currently 20. Is equal to. Perfect. So since it is equal to, now this is the statement after the question mark is the statement that will be executed if the condition is true. Which means since this condition is true now, it will set result equal to num is greater than 20. If the condition was false, it will set it equal to num is small. Let's try to print out result 2. Let's get rid of the if statement. We don't need that anymore. Let's print this out and see what we get. You see, it says num is greater than 20. Let's reduce it to maybe 5. Run this. It says num is too small. So it's still like an if statement, but a shorter way of writing if statement. But like I said, this is only better, or you only use this if you know your if statement is just going to have one line of code inside the code block. If it is going to have more than one line of code, this approach would not work for you. If you've got a question about this, please go ahead and ask it. Let me check the chat if we have questions. Somebody says, please send me invite from your end. Invite to where? Okay, Nick, please send the link for the WhatsApp group he posted. Oh, did it disappear? I'll resend that. I just resent that. All right, I just resent that. And while you're visiting the WhatsApp group, I also have a YouTube channel where I virtually share most of the video recordings. Like this class right now, the video recording will be made available immediately after this class. Highest maybe 2-3 hours time. I might upload it, or worst, maybe later tonight, maybe because of some editing I have to do on the video recording. So that will be made available. If you're currently not subscribed to the YouTube channel, you can do that. Let me see. Do I still have the link here? I should have the link.
Hey, what's up, everybody? How are you doing? In this video.
All right. Where's the link to that? I can't really find. Sometimes I find this link. Just join the WhatsApp group. I'll paste the link there. Oh, no. Okay, I found it. Perfect. So I just pasted the link there too. If you're currently not subscribed, you can do that so that when I upload videos, you can get access to them. We also have some videos that are there. Some of the videos for our past JavaScript classes. I think I have a Git and GitHub video there. So for those of you who are still not familiar with Git and GitHub, you can look it up there. So basically, this is just the ternary operator. Okay, and this is what they refer to whenever they talk about ternary operator. It's just the shorthand method of writing the if statement. And it's just always mostly on a single line. I don't think I've seen a ternary operator on more than one line. It's always a single line. And the truth being that I prefer writing this than writing, look at this single line of code compared to this that we have here. Okay? So whenever I want to have an if statement that looks basic like this, I prefer going with the ternary operator there. All right? Okay, great. So I guess no questions yet means we don't really have any questions. And at this point, I would still say if you have a question, please go ahead and ask. Probably after the class, if that's when you remember your question, you can go ahead and paste, write the question on the WhatsApp group. if you've joined, go ahead and ask the question on the WhatsApp group, and I'll try as much as possible to answer your question. In fact, there are people there that would answer it before I talk. There are plenty there.
I have a question.
All right, go ahead.
Okay, yeah, for the single quote and the double quote, we can use them interchangeably, right?
Yes.
Because I
Yes.
see you.
Yeah, in JavaScript, when you're creating a string in JavaScript, you can go with any of the quotation mark, but there is a catch to it. There is a way you mix it up and you don't mix it up. After this class, I'll paste a link to the very first JavaScript class we had. We talked about strings and how to work with the quotation mark. But basically, you can use any of this to start, double or single. But the problem comes when you want to write a string that has quotation mark. Maybe you want to say something like, Mary said she's coming. You know, that kind of string now, we have an apostrophe, right? And you know, apostrophe is just quotation mark. So that is where you might have to twerk it a bit. But like I said, if you check on my YouTube channel, I have a video addressing, I think our very first video, free YouTube JavaScript class, we talked about the basis of JavaScript and I introduced that to them. What I'll do is I'll paste a link to it immediately after this class. And if you can go watch it, you can do that. But I'm currently trying to make some other videos around JavaScript, HTML, and CSS. It's just because of my work and time. I can editing the video is taking really long, but those are still some of the topics I discussed in some of the videos. So hopefully when I upload it, you can look it up. But basically, when you're creating a string in JavaScript, you can use double quotes or single quotes. But like I said, when you want to have a string like this, so if I want to have Mary said she's coming. If you look at this now, because of the presence of this single quote here, if I want to wrap this string in quotes, it makes sense to use double and not single anymore. That's because whenever JavaScript sees a quotation mark, it looks for the next quotation mark to form a string. So if you start with a single quote, that means from this single quote to this single quote is your string. This part is no longer part of the string. But if you start with a double quote, it will look for the next double quote to form the string, which is this one here. So this becomes valid. On the other hand, if you want to use double quotes for the quotation mark there, you want to make sure in this case now you start with a single quote. That means when JavaScript sees this single quote, it is when it sees this second single quote, it will mark it as the end. All right? Do you catch that?
Yes, I got that. Yes,
all right.
Yes.
So that is just...
Secondly, sorry.
All right.
Secondly, yeah, I don't know if like a mini project that can be given something like an assignment to.
I have
based on what you have taught us today. So
okay, I think I have a project on my YouTube channel. It's a shopping. Let me see if I can see the link. It's a shopping cart app we built. But that being said, in our next JavaScript class, we'll be building projects. Like project is what we are coming to build. I'm not talking about all these bases anymore in our next class. So basically based on projects. Okay, that's what we'll be dealing with in the next class. I'm no more fine. What I'll be doing majorly will be, if I have any topic I want us to discuss, I will make a video on it, upload it. But when it comes to having classes like this, we'll be focused more on building projects now. Okay, so I'm trying to load this YouTube video. Okay, look at this video. I have this video. It's on my YouTube page on building a fashion landing page website. We built this using HTML, CSS, and a little bit of JavaScript. I think about 2 students went ahead to implement add to cart on the project. Let me see.
I live in Jersey City, New Jersey,
Let's
and I went from
leave YouTube to play its adverts.
Hey, what's up, and
All right, this is the video, and you can see we made this shopping cart in the video here. So if you're looking for something to play around with, using your HTML and CSS and a little bit of JavaScript knowledge, you can come try this out. You can come try this out here. And like I said, in our subsequent classes, we'll be focused more on building projects instead of just random classes like that.
We're developing this fashion.
So you can go work on this first and let's see how it goes. All right, any other question? All right, in the absence of none, I'll be drawing the curtains here because, like I said, there's something about classes we do not talk about, static classes, okay? Static classes. Go to W3 School, okay, and check out their JS documentation on classes. If you don't know W3 School, open your browser, search for W3 School, okay, W3 School. It should come up for you. And once it's up, you can go ahead and click on, go to the website. Click on the option to learn JavaScript. This is it here, learn JavaScript. And if you scroll down to the very bottom, you see their documentation on classes. So we've covered the basic intro, the concept of inheritance. This is the only one we could not cover, static methods. So you can cover that too. And once you know this, you're already a guru with JavaScript classes, because those are the three major topics there. Okay, so you can look it up. And that will be it for this class. Thank you guys so much for joining us. If you're not part of the TechLeap community, please use the link provided, the WhatsApp link, to do that. If you are not subscribed to the YouTube channel, please do that. So when I upload this video, you get access to it. Ellen, you're raising up your hand. What's up? You have a